Welcome to module 9.10. In this lecture video, I'm going to show you how to solve absolute value inequalities. So rather than using equal signs, now I'm going to turn them into inequality. So here I have two different definitions. One of them is using less than, the other one is use greater than. Okay, so there was something we mentioned back in compound inequality regarding to how do you read things like this. Well, when you read things like this, back in module 9.7, I believe, this is basically a compound inequality. So if you read from the variable, what it's saying is this ax plus b, whatever this was inside the absolute value, got to be greater than negative c, and it also got to be ax plus b got to be less than what? That positive c. Okay, so again, once I isolate my absolute value, okay, once I isolate my absolute value, all right, then I'm gonna set up two equations. One of them is gonna be less than that positive c, but the other one where I have to push my negative sign to become a negative c, or whatever that number is going to be. But since I'm dividing both sides by negative, that's why my inequality has to change. Remember in the previous video, I wrote something like negative parenthesis ax plus b is equal to c, and what we did was divide both sides by -1. Same idea here, but when I divide it by a negative coefficient, then my inequality that was less than, now it will switch to greater than. Okay, and same go with starting off with greater than. When we use greater than, okay, for the absolute value equation or inequality, we are using the word or always. So we take whatever is inside the absolute value, set it to be greater than that c, but then the other equation got to be less than negative c, because again it was supposed to be negative parenthesis ax plus b greater than c. So when I divide both sides by -1, trying to move the negative sign onto the right side, the inequality got to what? Got to switch over. That's why it's become that. Alright, so greater than is using the word or. Less than is basically using the word and. Alright, so let's see if it's true. So this is less than equal to isolate my absolute value, I'll move this over. So step number one, solving the inequality, expressing interval notation, because I'm dealing with inequality again, so interval notation comes back out. So this is absolute value of 2x minus 7 is less than equal to positive 7. So I'm good to go. Alright, so now set two different equations. Take that 2x minus 7, set it to be less than equal to that positive 7, and take the same 2x minus 7 and set it as greater than equal to that negative 7. Because if the other side got to be negative instead of positive 7, the inequality got to be switched. Alright, let's move my -7 over for both equations. So that will be 2x less than equal to 14. This is 2x greater than equal to 0. So x is less than equal to 7 here. Divide both sides by 2. This x is greater than equal to 0. So I'm actually bound by the word and. So I'm looking for a number that is less than equal to 7. And it also got to be greater than equal to 0. Okay, so that will be go to the right side of 0. So when I use blue here, the overlap, the one that's go to the left and also go to the right, got to be the green part. Okay, so my solution got to be less than equal to 7 and also bigger than equal to 0. That means my interval notation got to be from left to right, from 0 to 7. Okay. All right, this one is greater than. Greater than is using the word or. So I'm going to move my negative 3 over. So this time will be absolute value of 2x minus 9 is greater than or equal to 3. So once the absolute value term is isolated, I can split them up into two different equations. Take whatever I got inside the absolute value, set it to be greater than or equal to that 3, positive 3, or I can take whatever is inside the absolute value, set it to be less than or equal to that negative 3 now, okay? Because when I set it to be negative 3, the inequality got to change. Alright, let's quickly move the negative 9 over. So that's 2x greater than or equal to 12, x is greater than or equal to 6, right? This one is 2x is less than or equal to positive 6. Negative 9 come over, become positive. Divide both sides by 2, x is less than or equal to 3. So now I'm looking for numbers that are greater than or equal to 6 using a bracket to the right side of 6. Or I'm also looking for, I can also look for answers that are less than or equal to negative 3. So that'll be from negative 3, go to the left. So by looking at my graph, my interval notation for step number 1 got to be from negative infinity all the way to negative 3 using bracket, union, or my answer can be from 6 using a bracket, keep on going to the right. Alright, so now I'm just going to begin to show you different variation, okay, of problems. So this one, just like the one with the equal sign, I got two terms on the left, so let's move the negative 9 over. That's 3 times absolute value of y minus 3 is less than positive 9. So to get the absolute value by itself, I got to divide both terms by 3, or both sides by 3. So now my absolute value of y minus 3 is less than 3. So now the absolute value is by itself. Then I can actually split them into two different equations. Take what's inside the absolute value, set it to be less than that positive 3. So what's less than? Less than is what? And, right? Less than is and. And I will take whatever is inside the absolute value, set it to be greater than that negative 3 on the right side. Push the negative sign to the right side. Alright, so let's move the 3 over. That's y is less than 6. And negative 3 go over, become positive. So that'll be y is greater than 0. So my answer that I'm looking for got to be less than 6. That will be to the left side of 6. And it also got to be greater than 0. That would be to the right. So my interval notation got to be, my answer's got to be from 0 using parentheses all the way to 6. Okay, that's how it is. Just by looking at this graph, we can write interval notation. Alright, let's look at a couple more. So this one is just same thing. Got two terms here on the left side, so let's move this positive 7 over. So that gives me 3 times absolute value of y minus 3 is less than or equal to 6, I believe. Divide both sides by 3. That's absolute value of y minus 3 less than or equal to 2. So now we will set whatever is in. So once this absolute value is by itself, set whatever is inside the absolute value less than or equal to that positive 2, and set whatever is inside the absolute value greater than or equal to that 2 become negative. So one answer, y is going to be less than or equal to 5, and the other part would be y is greater than or equal to 1. Alright. Negative 3 go over, become positive 3. So I'm looking for numbers that are less than or equal to 5. Let's go to the left side 5. And I'm also looking for numbers that are greater than 1. So 1 go left, 1 go right. Okay, so with the word and in the middle, I'm looking for a number that got to be bigger than 1 and, okay, less than 5. So that got to be everything in between 1 to 5. So my interval notation gotta be bracket 1 to 5. All right, so let's try this one, okay? The one with a little bit of fraction in it. All right, do the same procedure. Let's move the positive 4 over so my absolute value term can be isolated, greater than or equal to 3. So now I'm gonna set whatever is inside this absolute value greater than or equal to that positive 3, or I'm gonna set what's inside the absolute value less than or equal to negative 3, because I'm pushing the negative sign onto the 3, inequality got to change. So since I only got 2 terms, if I multiply both terms by 3 to clear the fraction, that gave me 3x minus 3 still on the top is greater than or equal to 9. The other one, alright, multiply both terms by 3 to get rid of that fraction. That's 3x minus 3 is less than or equal to negative 9. Alright, move the negative 3 over to the other side. This is 3x greater than or equal to 12. X is greater than or equal to 4. Or my answer can be, this is 3x less than or equal to negative 6, right? Negative 3 will become positive. Divide both sides by 3, x is less than or equal to negative 2. So I'm looking for numbers that are less than or equal to negative 2. That's bracket. Less than means everything to the left of it. Or my answer can be bigger than or equal to 4. So that's 4. Everything go to the right because it's greater than. So put the two together, my answer, my solution, or my interval notation can be from negative infinity all the way to negative 2 using bracket, or my answer can be from 4, keep on going to the right to infinity. Okay, so we will end up doing something similar to this union and intersection when we are in college algebra dealing with domain, especially dealing with domain. Okay, so this is the first time we introduce interval notation in module 9. The next time you probably see this will be in college algebra. All right, so that will conclude this lecture video on how to solve absolute value inequalities. Okay, and they are also related to the word or, the word and. All right, thank you for watching.